Let's look at population densities. In areas where everyone lives in houses, the density is 4 to 5 units per acre. Large apartment buildings can reach 100 units per acre. So we know we could fit way more people in apartments than in houses. And worldwide, 1.5 million square kilometers of land is used for infrastructure, so if everyone lived separately in houses, our global capacity would only be 1.8 billion people. And with large apartment buildings, we reach 37 billion people. With a global population of 7.8 billion, about 4 times what it was 100 years ago, humanity would need to either replace neighborhoods with complexes or expand into unused habitable land. Now let's look at farming. Farming uses 50% of all habitable land, and we produce enough to feed 10 billion people. But what if, going back to the housing analogy, we could create apartment complexes of farms, a multi-level building that can grow the same amount of food in a fraction of the land and increase our food production. Hello everybody, welcome to Future Leaps, a channel where we look at everything in science, technology, and engineering to learn about what they are and discuss what potential they have for the future. This video we will be covering vertical farms, which is a building that can produce food much more efficiently than a typical farm. There are already some profitable vertical farms, and I think we can expect to see a lot more in the near future. Let's start by learning how a traditional farm works. Farms use crop rotation, where different fields grow different crops for a year, and then take a year off to recover nitrogen in the soil. This can be done by letting it lie fallow, or by planting a legume, such as clovers. So, for example, in a 2-field crop rotation, the farmer would plant food for a year on one field while letting the other one lie fallow, then switch the following year. This means the farm has 50% efficiency and uses twice the amount of land. There are 3-field and 4-field farms as well, but as the number goes up, the amount of human labor needed does as well. Traditional farms are exposed to external variables that can affect the quality of the food or the output of a farm. Nature is unpredictable, and changes in sunlight, rain, and wind can affect crop growth. Several natural disasters have destroyed farmland and crops, leaving many farmers in a financial crisis. Crops are also sprayed with pesticides so that insects don't eat and ruin them. And lastly, they use a lot of fresh water since the soil needs perfect conditions. Overall, about 70% of fresh water is used for agriculture. The last major issue is that farms are less efficient in certain climates or countries. We have enough food to feed the world, but 1 billion people are undernourished because some countries are not optimal for growing food. They have to import it from other countries, which is expensive and hurts their own economy. In addition, the importing and exporting of food is bad for the environment and for the quality of food. Food is responsible for 1/4 of all global emissions, since on average, food travels 2,400 kilometers to get from the farm to a store. To add to it, this length of time means food is more likely to taste bad, lose nutrients, or spoil and get thrown away. Farming further hurts the environment because the large plots of land are invasive to local flora and fauna. As more land is used for farming, forests are cut down, and some animals will go extinct. So to sum up, traditional farming causes high water use, land use, pesticide use, carbon emissions, and makes global hunger harder to solve. And with global populations rising, this problem will only become worse. Fortunately, many small companies are creating vertical farms, which address most, if not all, of these issues. It is an indoor farm where seeds are planted under UV lights, and their roots are given nutrient-dense water. There are 3 different types of farms: hydroponics, aquaponics, and aeroponics. Hydroponics involves having the roots submerged in water and nutrients pumped into the water. Aquaponics is the same idea, but instead of a nutrient pump, fish are put in the water. Fish will naturally produce nutrients in their waste, and the fish can be harvested along with the crops. Aeroponics is the same concept as hydroponics, but instead of the water running through the roots, it is sprayed as a mist onto the roots. All 3 methods use less water than traditional farms. Vertical farms remove the need for soil, as the water will provide all the nutrients necessary. As a benefit, less water is needed per crop since the roots get the water in a direct and controlled way. When growing lettuce, hydroponics use 13 times less water than conventional farms, and aeroponics is even better. Since it is a mist, it can be up to 10 times better than hydroponics. So for every liter used to grow lettuce, an aeroponic farm can do the same with 8 milliliters. Now let's look at pesticides. Since all the crops are indoors, the farmers can regulate what comes in and out. As a result, practically no pesticides are used, which is both cheaper for the farmer and healthier for the consumer. When looking at land usage, vertical farms can produce the same amount of food in 1/10 of the expected land. This is for many reasons. 1. Vertical farms can run year-round rather than needing to let land lie fallow for a fraction of the time. 2. Vertical farms are indoors and not exposed to weather, so as a result, temperature, light levels, humidity, and air quality can all be controlled and crops can grow better. And 3. Vertical farms are not as restricted by height, and multi-level farms can allow for more seeds in the same amount of land. A common concern with vertical farms is the infrastructure costs. However, many of the startup companies use abandoned warehouses, shipping containers, or underground tunnels to repurpose empty real estate and be closer to the urban areas. As a benefit, produce will take less time to reach the consumer. As vertical farms become more productive, the traditional farms that are no longer needed can then be repurposed or restored to wilderness. It is estimated that for every acre of vertical farming, 20 acres of farmland will return to its natural state. Now let's look at emissions. Vertical farms use a lot of electricity. LED bulbs are getting more efficient, but they still use a lot of power. Heating and cooling of the building also uses power. Traditional farms use very little electricity in comparison. If the vertical farms rely on renewable or nuclear energy, then the emissions would be negligible, but especially in the US, most energy comes from fossil fuels. On the other hand, though, the transportation of food is where vertical farms have an upper hand. As said before, the average distance that food travels is 2,400 kilometers, but vertical farms can be directly next to urban areas, bringing this number potentially down to 100 kilometers. Also, as vertical farms replace traditional farms, more wilderness will be preserved and the demand for open land will drop, so deforestation will hopefully slow and more emissions can be absorbed. Overall, vertical farms are better for the environment, but they should be powered on clean energy. Now, there are some downsides to vertical farming. For one, the variety of food that can be grown is smaller than the variety that can be grown on a traditional farm. For starters, vertical farming does not address animals, which is the worst type of farming in terms of how much land and resources they use. Vertical farms can only grow a small variety of leafy greens at the moment, as grains are not cost-effective and fruits are more complicated. However, this may be possible in the near future with further development. It is also still more expensive than traditional farming. Most companies need millions of dollars of funding to even cover the fixed costs, and many years before they can become profitable. The cost will likely keep dropping, since LED lights for the UV lighting are drastically cheaper and have a longer lifespan than they did a couple years ago. Also, as more research is done, it may be possible to get the same results using less light or less energy, and that optimization will definitely occur as these farms become more common. However, these downsides should not stop us from pursuing this technology. The truth is, current farming is not sustainable, and we may run short on fresh water and food if population keeps rising. It is also very damaging to the environment, and if we want to slow climate change and preserve nature, an alternative must be used. I see a lot of future potential for vertical farming. With over half of the world's population in urban areas, they can get higher quality, locally grown food. We could see districts or large buildings used for farming in areas where farming certain foods would typically not be possible, and this can help solve global hunger and better preserve our planet. It could even be used to advance space exploration, since being able to farm food with less water and less land means that space stations or planetary bases could grow their own food and become more self-sufficient. In my opinion, the benefits greatly outweigh the costs of vertical farming, and I hope to see a further push for it in the near future. Thank you so much for watching to the end. Please consider subscribing, and as always, here's a fun fact.